Hello everyone. We'll start with the revision of dispersion. Now, dispersion can only be studied if you are well aware of the facts and formulas and concepts of central tendency. Otherwise, we can't do this. Now, in dispersion, before whenever we get a statistical data or any table, the first and foremost thing that we calculate is central tendency, mean, median, mode. Okay, that's why central tendency are known as averages of first order. The second thing that we use mainly for comparison that we find is dispersion. And that's the reason dispersion is known as averages of second order. With this video, I'll attach the PDF, the theory also. Do go through the theory for all the questions. Now, dispersion first, it is known as averages of second order. Now, when we talk about dispersion, what does it actually gives us? It gives us the scatteredness of the observation around the central tendency values. So if my average is 30 and the rest of the averages out of 50, the rest of the averages are very diverse. Someone is 50, someone is 2, someone is 45, someone is 12. It's very, very far away from the actual central tendency value. So the data are very scattered. The dispersion value will be high, which is wrong. That means the data won't be consistent, the data is not good. But if your average is 30 out of 50 and the data, the values, the rest of the observations are very closely knitted around. Someone is 35, someone is 42, someone is 25, someone is 28. They are very closely bounded near 30. That means the dispersion value, the scatteredness is less. The dispersion value will be less. The data is more consistent. The data is a good data. So we want that the dispersion value should be smaller. So dispersion gives us scatteredness of the observation around the central tendency values. Now, in dispersion, we talk about two varieties. First is when we use raw or the original data. For example, if you tell me your marks, all the subjects marks, and there are 7 students in the class, then just by hearing your marks, I won't be able to decipher whether which student has done the best out of the lot. But this is raw data or the actual data. But if you tell me that in percentage form, I can be very quick in saying, okay, this student has the highest percentage, so A has scored the highest, A has done the best performance. So whenever we deal with actual or the raw data, the comparison, the relative things become difficult. But when we convert those things into percentages or ratio, it becomes easier for us to compare. So actually dispersion is absolute dispersion where we use raw and original data. But for us to facilitate comparison, we convert those absolute measures of dispersion into relative. And that is known as coefficient. We convert each of them into percentages, first ratio, and then multiply by 100 to get them into percentages. That helps us to find out the percentage and helps to hence facilitate comparison. So whatever is the actual rule of dispersion that is applied on absolute. Relative is something that we calculate on an extra. Okay. So dispersion, two varieties, absolute and relative. Absolute uses raw or the original data. Relative converts them into ratio or percentages. Absolute, since it's using raw data, it has unit. Relative is unit free. Absolute has 4 varieties: range, mean deviation, quartile deviation, standard deviation. Absolute just uses the word coefficient before it. Again, 4. Coefficient of range, coefficient of mean deviation, coefficient of quartile deviation, coefficient of standard deviation, rather coefficient of variance. The best out of the lot is standard deviation. All the good things are standard deviation. Most widely used, most common, most useful, everything is standard. In case of central tendency, in case of central tendency, everything good was about mean. Now, in the entire central tendency, mean, median, and mode, all of them were affected by origin as well as gain. So if I added something or multiplied something, for example, y is 2 minus 3x, then mean of y is 2 minus 3 mean of x, median of y is 2 minus 3 median of x, and same goes for mode also. But when it comes to dispersion, now remember, mean, median, mode could have been positive, negative, anything. Entire dispersion chapter can never have negative answer. Dispersion is always positive. Always. It can be 0, but it cannot be lesser than 0. It can never be negative. It's always non-negative. Now, entire dispersion chapter is not affected by origin, but they are affected by scale. Entire dispersion. So when I say dispersion, I'm talking about absolute dispersion. So or anything that you add or subtract, that will be ignored. Anything you multiply or divide will be taken, and you cannot have a negative sign. So if I say y is equal to 2 minus 3x, so range of y, so yes, added 2, that's ignored. We have like multiplied x by minus 3, you cannot use a minus sign. So 3 into range of x. Standard deviation of y will be 3 into standard deviation of x. Mean deviation of y, 3 into mean deviation of x. The entire dispersion chapter has this common property. Okay. So central tendency plus minus into divide everything matters. In case of your dispersion, anything that you add or subtract doesn't matter. If you multiply or divide, only that is considered. Clear? Online clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Let's talk about each of the things. First, range. Range is largest minus smallest observation. So if it is individual series, and coefficient of range is L minus S by L plus S into 100 into 100. Now, if I have individual series, the data is 2, 3, 5, 10. Range will be largest minus smallest, that is 8. Coefficient of range, it will be largest minus smallest by largest plus smallest into 100. Answer?
66.6.
66, sorry. 66.666 of 67. Clear? Then after range, we use range only when we are talking about weather forecast or quality control. Otherwise, it's a nonsense term. Now, what does it use all the data? No. Is it affected by extreme observation fluctuation? 100%. Because it only uses extreme data. It only uses the smallest and the largest data. So it is highly affected. Then if I have a discrete series, X and F, the year 10, 11, 12, 13, 3, 2, 4, 5. In this case, our range will be values of X. Highest value minus the lowest value. 13 minus 10, that is 3. If I want to find coefficient of range, largest minus smallest by largest plus smallest into 100. Answer?
13.04.
13.0.
Now, if it is a continuous series, remember for the entire statistics chapter, the continuous data has to be exclusive, really race. So if I tell you 0 to 10, 10 to 20, 20 to 30, your frequency is 5, 3, 2. Then range, the highest one minus the lowest one. So 30 minus 0, that's 30. Okay? But if the data is not exclusive, if I tell you it is 10 to 19, 20 to 29, 30 to 39, and the frequency is 3, 4, 5, then we need to first find out class boundary. We need to make it exclusive. Right now it's inclusive. Here the difference is 1 unit. We divide 0.5, 0.5. All the upper limits increases by 0.5. All the lower limits decreases by 0.5. 9.5 to 19.5, 19.5 to 29.5, 29.5 to 39.5. So our range, highest possible value minus the lowest. 39.5 minus 9.5, that's 30. Coefficient will be the same formula. Any doubt?
No, ma'am.
No.
Now, if I say that y is equal to 2 minus 3x divided by 5, range of x is 10. I want to find range of y. So as I said, whatever you add and subtract is ignored. Whatever you multiply and divide is considered. So with x, whatever you have multiplied and divided, that will come. Rest everything vanishes and it can't be negative. So it will be 3 into range of x by 5. So 3 into 10 divided by 5. So 6. Am I clear?
Yes.
Yes, ma'am.
All of you clear?
Yes.
Yes, ma'am.
Yes.
Yes. So this is range for us. Any doubts?
Oh, ma'am.
Oh, ma'am.
Then we move to quartile deviation. I hope you all know how to calculate quartiles.
Yes.
So quartile deviation, first we find out interquartile range between the quartiles, that is Q3 minus Q1. First quartile, third quartile. Then quartile deviation is basically semi-interquartile range. Q3 minus Q1 by 2. When we talk about coefficient of quartile deviation, it will be Q3 minus Q1 by Q3 plus Q1 into 100. Clear? So for this, the only thing we need to know is finding Q1 and Q3. If we know that, our sum is extremely easy. Yes? Can I remove this? So remember, for quartile, for median, those are positional values. That means it is important to arrange the data in an ascending order. So if I talk about individual series, I'm giving you in arranged format only. 160, 200, 208, 210, 220, 250, 300. It's already arranged. This is individual series. The formula that we adopt is n plus 1. So Q1 is n plus 1 by fourth observation. Number of observations are 7. 7 plus 1 by fourth observation. That is second observation. Second observation is 200. Q3, it is 3 times n plus 1 by fourth observation. That is sixth observation. That is 250. So automatically quartile deviation Q3 minus Q1 by 2, 25, and coefficient of quartile deviation Q3 minus Q1 by Q3 plus Q1 into 100. How much?
11.1.
Yeah. Guys, clear?
Yes, ma'am.
Yes, ma'am.
Yes,
Now,
ma'am.
sometimes it may
Yes,
come in
ma'am.
decimal also. Suppose I'm giving you in the arranged format 55, 60, 70, 90, 90, 110, 120, 130, 145, 150, 145, one more time, 155, and 170. Number of observation here is 12. So Q1 will be 12 plus 1 by fourth observation. 3.2 fifth observation. So this will be third observation plus 0.25 into fourth minus third. Do you all remember this?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So third observation 70.25, fourth minus seventh, 70 plus 5, answer is 75. Q1 is 75. Is it okay? Find out Q3. Find Q3. Q3. This is 3 times n plus 1 by fourth observation. So it will be 9.75th observation. So 9th plus 0.75 into 10th minus 9th. So 9th observation 145 plus 0.75. 10th is also 145. So that's 0. So 145. Any doubt?
No, ma'am.
No, ma'am.
Now, quartile deviation, it's Q3 minus Q1 by 2. Answer? Thirty-five.
35.
Coefficient of quartile deviation, Q3 minus Q1 by Q3 plus Q1 multiplied by 100.
15.90.
31.8.
Yes, ma'am.
All of you got the answer?
Yes, ma'am.
Ma'am.
Now, if the data is in discrete format, what was discrete? I have x and frequency both. So x 150. Again, it has to be arranged. Make sure. 153, 155, 157, 159, 161, 163, 165, 167, 169 comes frequency 25, 21, 28, 20, 18, 24, 22, 18, 23. If it is frequency, you have to calculate cumulative frequency. Calculate that. Calculate cumulative frequency. 25. 25 plus 21, 46. 46 plus 28, 74. 74 plus 20, 94. 94 plus 18, 112. 112 plus 24, 136. 136 plus 22, 148. 148, sorry, 158. 158 plus 18, 1.
76.
Fine. In this case, the formula is still the same. Q1 is n plus 1 by fourth observation, 50th observation. So what we see is we want this 50 in the CF column. If you don't have the same number, you see the immediate greater number. So you find the CF which is just equal or greater than 50. So just greater than 50, 74. 74 is written for which number? 157. So Q1 will be 157. Am I clear?
Yes,
Yes,
ma'am.
ma'am.
Find
Yes,
Q3.
ma'am. 165, ma'am.
165.
3 into n plus 1 by 4th observation, 150th observation. Again, in the CF column, we don't see 150. We see 158. 158 is for 165. So now quartile deviation, Q3 minus Q1 by 2.
4, ma'am.
Coefficient of
Four.
quartile deviation, same formula.
2.48.
Very good. Q3 minus Q1 by Q3 plus Q1 into 100. Answer 2.4.
2.3.
Clear?
Yes, ma'am. Yes, ma'am.
The same thing we also calculate for continuous. Now, for continuous, that is with the interval one. See the formulas. Q1 class. This is the class with cumulative frequency equal or just greater than n by 4. Then the formula of Q1 was L plus n by 4 minus Cf by F into H. For Q3 class, it is the class with cumulative frequency equal or just greater than 3n by 4. So Q3 L plus 3n by 4 minus Cf by F into H. For example, the rest of the formulas are same. Interval 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30. Frequency 3, 9, 15, 23, 30, 20. Again, we will need a cumulative frequency column. 3, 3 plus 9, 12, plus 15, 27, plus 23, 50, plus 30, 80, plus 20, 100. So for Q1, we first calculate n by 4. N by 4 is 25. This is n. So we don't have CF 25, but we do have a column with CF just greater than 25. Which interval will be Q1 class?
10 to 15.
This is Q1 class. So L is the lower limit. Remember, the data has to be exclusive. If it is not exclusive, we make it exclusive. This will be your frequency. Cumulative frequency is taken from the previous case. Q1 L plus n by 4 minus Cf by frequency into H is 5. Calculate.
15, ma'am.
No.
15.33.
Yes. Did you all get this?
Yes, ma'am.
Now, for finding Q3, we calculate 3n by 4. 3n by 4 is how much?
75.
So, which one will be Q3 class?
20 to 20.
So, Q3 L plus 3n by 4 minus Cf, the previous one, by F into H.
24.16.
17. Approximation. So now quartile deviation Q3 minus Q1 by 2. Answer
4.9.
Works. That's fine. Coefficient of quartile deviation. Q3 minus Q1 by Q3 plus Q1 into 100. अब by 2 वाला value डाल दी. It's not quartile deviation in the numerator.
25.55%.
Very good. All of you got the answer?
Yes, ma'am.
Now, if same property, if y is 5x minus 7, quartile deviation of x is 3, then quartile deviation of y will be
15.
15.
5 into quartile deviation of x, whatever is added and subtracted is vanished. So 5 into 3, that's 15. Clear?
Yes, ma'am.
Now, properties of quartile. Does it use all the observations?
Yes.
No, it does not. It does not. It will never use the first interval and the last interval. It can never. Before Q1, 25% of the data. After Q3, 25% of the data. So quartile deviation also uses the central 50% of the data. It does not use all the observations of the data. It is affected by extreme observation fluctuation, not at all. Now, this is the only measure of dispersion which can be used for open end. Suppose in this particular case, rather than 0 to 5, if I would have written here less than 5, it would not have mattered. I would have still done the sum normally. And this can only happen in quartile deviation. So if you get such an open-end class distribution and it tells you find an appropriate measure of dispersion, that means they've asked you to find out quartile deviation. Clear?
Yes, ma'am.
So quartile deviation is not based on all the observation. It only uses the central 50% of the data. It is not expected by the extreme observations. It is the only measure of dispersion that can be used for open-end classes. Any doubt till here?
No, ma'am. Ma'am.
Clear? The next that we talk about is mean deviation. The actual formula is arithmetic mean. This is arithmetic mean of deviation. Deviation is difference. Okay? Deviation, basically absolute deviation. In dispersion, we only use absolute deviation. Okay, we never use the negative sign. So deviation D this is difference x minus a. Now this a can be mean, median or mode. It can be mean, median or mode. So mean deviation can be calculated from mean, can be calculated from median, can be calculated from mode. So mean deviation is the arithmetic mean of absolute deviation. So arithmetic mean is summation absolute value of d by n, summation x by n, or summation fx by summation f. Now, how do you get the deviation? That will be determined by the question. So what are our steps? First, calculate mean, median or mode depending upon what is said in the question. Calculate mean, median or mode depending upon what is given in the question. Second, find deviation. That will be x minus mean or x minus median or x minus mode? That question will tell us. Third, either mean deviation is summation d by n if it's an individual series question, or it will be fd by f if it is a frequency question, discrete or continuous. Okay. Now this x for continuous, it will be the mid value. For continuous series, x is mid value. We have to calculate that. For continuous series, x will be mid value. Then coefficient of mean deviation. It will be mean deviation by A into 100. If you have calculated the mean deviation from mean, divide by mean. If you have calculated the mean deviation from median, divide by median. If you have calculated the mean deviation from mode, then divide by mode. The question, if nothing is mentioned, find from mean. Let's try. Can I remove this? First question. X, individual series question first. X is 5, 8, 11, 12, 14. It is not necessary for the data to be arranged until unless you are finding out median. So first we have to calculate this from mean. So first step, calculate mean. What is mean? How will we calculate mean?
Sum of the thing divided by number.
Sum of the observation by number of observation. This will be
10, ma'am.
10. Clear? Then we need deviation. So now you can directly use calculator. Mean deviation will be summation absolute deviation by number of observation. From every number, subtract 10 and add them. So you can do 5 minus 10 absolute value m plus. 8 minus 10 absolute, change the sign m plus. 11 minus 10 m plus. 12 minus 10 m plus. 14 minus 10 equal plus MRC divided by 5.
Two point eight.
0.8. All of you got the answer?
Yes.
Yes, ma'am.
Now, coefficient of mean deviation will be mean deviation. We used mean into 100. Mean deviation 2.8 divided by mean 10 into 100. Answer
28.
20.
20. We don't write percent. All of you clear? Yes,
Yes, ma'am.
For this data, find from mean. Find mean deviation from mean. Sum of the observation by number of observation. Mean is
20.
mean deviation. Sum of absolute deviation by number of observation.
6.28.
6.28. Coefficient mean deviation by mean into 100.
31.42.
Clear?
Yes, ma'am.
Yes, ma'am.
Then individual after that discrete X and F. 10, 11, 12, 13, 3, 12, 18, 12. So first calculate the total of mean. What is the total of mean? What is total frequency? 45 summation f. So mean will be summation fx by summation f. 10 into 3 m plus 11 into 12 m plus 12 into 18 m plus 13 into 12 equal plus MRC divided by the total frequency 45.
11.86.
Rest of you?
Yes, ma'am. 11.86.
Then coefficient, same formula. Mean deviation by mean. Mean was? Oh, my fault. Mean deviation. Summation FD by summation F. So what we do is 10 minus 11.87 sign change multiply by 3 m plus 11 minus 11.87 sign change multiply by 12 m plus. From every x I'm subtracting the mean. Multiply by 18 m plus 13 minus 11.87 multiply by 12 equal plus MRC divided by total frequency. This is basically absolute value of D and this is the frequency. What is mean deviation?
0.7.
0.7.
1.
Very good. Now coefficient. Mean deviation by mean into 100. How much?
5.9.
Sorry?
5.98.
Rest of you?
Yes, ma'am. 5.98.
Done? For continuous class interval, say 2 to 4, 4 to 6, 6 to 8, 8 to 10, frequency 3, 4, 2, 1. Sum of frequency. So to calculate mean, we will need mid value x. What are the mid values? Mid values?
3579.
2 plus 4
3.5.
by 2, 4 plus 6 by 2, 6 plus 8 by 2, 8 plus 10 by 2. Now it became the previous sum. First calculate mean. Summation fx by summation f.
5.2, ma'am.
How much is mean? How much is mean?
5.2.
I couldn't hear. Mean is 5.2. Now mean deviation. Summation f into x minus x bar divided by summation f. So from here, subtract 5.2, change the sign, multiply by the corresponding frequency, add all of them, divide by 45. Divide by 10.
1.48, ma'am.
Very good. So 3 minus 5.2, change the sign. This is absolute value of D. Multiply by frequency M plus. 4 minus 5.2, change the sign, multiply by 4M plus. 7 minus 5.2, multiply by 2M plus. 9 minus 5.2 multiplied by 1 equal plus MRC divided by total frequency. We should get 1.48. Yes?
Yes, ma'am.
All of you got the answer?
Yes, ma'am.
Coefficient of mean deviation. Mean deviation by mean into 100. Answer? Hmm?
28.46.
All of you got the answer?
Yes, ma'am. Yes, ma'am.
So this was mean deviation from mean. Now, mean deviation can also be calculated from median. Agree? For median, it is necessary to arrange the data in ascending order. Question. Individual series. 5, 8, 11, 12, 14. Find median. Median. Median is middlemost value. Which one is the middlemost value?
11, ma'am.
Median is 11. Now the deviation will be calculated from 11. From all the x, subtract 11, add them, divide by 5. Divided by number of observation. What is mean deviation?
.6, ma'am.
Then coefficient of mean deviation. Mean deviation by median into 100. Answer?
23.63.
Clear?
Yes, ma'am.
In the discrete series, x and f. 80, 100, 150, 180, 200, 250. Frequency 16, 24, 26, 30, 26. Now to calculate median from here, what do we need?
CF.
CF 16, 40, 66, 96, 116, 120. So median, even number, it will be mean of 122 by 2, 61st and 62nd observation. So 61, 66 corresponding, 62, 66 corresponding, 150 and 150. So median will be 150. Yes?
Yes, ma'am.
Now, absolute value of D into F. So 80 minus 150 by 16 M plus. 100 minus 150, change the sign, multiply by 24 m plus. 150 minus 150, multiply by 26 m plus. 180 minus 150, multiply by 30 m plus. 200 minus 20, multiply by 20 m plus. 250 minus, sorry, multiply by 6 equal plus MRC equal divided by sum of the frequency, which is 120. For deviation, we always find mean. Before that, what you are finding, that's error. So mean deviation, summation FD by summation F. Answer.
39.51.
39.50.
Coefficient, mean deviation by median into 100.
26.33.
26.33.
All of you done?
Yes, ma'am.
Yes.
ma'am.
Now, continuous class interval 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30. Frequency 4, 7, 8, 2, 6, 3. We have to find median. To find median, what do we need?
CF.
CF.
CF. 4, 11, 19, 21, 27, 30. Formula n by 2, 15. So this is median class. So median L plus n by 2 minus CF by F into H. 10 plus 15 minus previous CF, same frequency, multiply by 5. Answer
12.5.
12.5.
all of you got the answer?
Yes, ma'am.
Yes, ma'am.
Now first we need X so that we can calculate the deviation. X is mid value. Mid values of these are 0 plus 5 by 2, 2.5, 7.5, 12.5, 17.5, 22.5, 27.5. Now to calculate deviation, 2.5 minus 12.5 multiplied by frequency, 7.5 minus 12.5 multiplied by frequency, 12.5 minus 12.5. Always press n plus. 17.5 minus 12.5 multiplied by frequency, 22.5 minus 12.5 multiplied by 6 m plus. 27.5 minus 12.5 into 3 equal plus MRC divided by total frequency.
6.33.
So mean deviation summation FD by summation F 6.33. Yes.
Yes, ma'am.
Coefficient
50.64.
3.66.
mean deviation by median into 100. Answer
50.66.
any doubts? We'll talk about now the last topic, that is standard deviation. standard deviation. Next. Symbol is sigma. It is basically root mean square deviation. In this case, the deviation is only calculated from mean. Only in mean deviation, we calculate from median and mode also. But in standard deviation, the deviation is only calculated from mean. So first we calculate the deviation. Deviation will be x minus x bar. Then square it. Mean of this. So either this or summation fd square by summation f and then square root of this. This is the formula for standard deviation. This is the formula for standard deviation. If you talk about variance, variance is standard deviation square. That means don't square, find the square. If you leave before the square root, then it is known as variance. Then we have CV. CV is coefficient of variance. Even though we say variance, but we use standard deviation by mean into 100. And as I said, we want to compare. While comparing, we always use CV. So if there are two datas A and B, and the coefficient of variance of A is smaller than that of B, so smaller value is good. Then A is a better data. A is more consistent. A is more consistent. A is more consistent. So basically standard deviation, summation x minus x bar deviation square by n. It is same as summation x square by n minus x bar square. We don't use the second formula, only for an MCQ point of view. Okay. And if it is frequency, summation f into x minus x bar square by summation f. But here the deviation will only be calculated from mean. Sigma is symbol. Add. Question. First individual series. 5, 8, 7, 11, 14. Find mean. First find mean. 5, 8, 7, 11, 14.
9 ma.
One sec. Here the mean is 9. Now we want x minus x bar deviation square. So 5 minus 9 square. Square is multiplied by itself. 8 minus 9 square. Keep on pressing m plus. 7 minus 9 square m plus. 11 minus 9 square m plus. 14 minus 9 square equal plus MRC divided by number of people.
N.
First variance.
10 ma.
Summation x minus x bar square by n. This is 10. And if you ask me standard deviation sigma, it will be root over 10. Root over 10 is
3.16.
coefficient of variance, standard deviation by mean into 100. Answer?
35.13.
Sorry?
35.13.
Yes, ma'am. 35.13.
Here? Next. Answer. 5, 10, 20, 25, 40, 45, 48, 70, 80. Tell me mean first.
$38.11.
1 second. Okay. Now find out standard deviation.
Ma'am, variance is 589.65.
Very good. Variance is before root over, so 589.65, and this is root over that.
24.28.
Very good. CV, standard deviation by mean into 100.
63.7.
63.7.
7.
Done?
Yes, ma'am.
Next. We'll go for discrete series, X and F, 5, 10, 15, 20, 2, 1, 4, 3. First, find out the total of frequency. It's better. Sum of frequency. 10. We want mean first. Summation fx by summation f.
14, ma'am.
14, ma'am.
Now, to find variance, summation f into x minus x bar square by summation f, which is 10. So, 5 minus 14 whole square. This is x minus x bar whole square into f, m plus. 10 minus 14 whole square into 1, m plus. 15 minus 14 whole square into 4, m plus. 20 minus 14 whole square into 3 equal plus MRC divided by sum of the frequency.
29.
29.
And standard deviation is root over this.
5.38.
5.3.
And CV, standard deviation by mean into 100.
38.46.
38.4.
46.
Clear?
Yes, ma'am.
Now, if I get a continuous data, the only extra thing will be finding the mid value. Find the mid value and make it discrete. Then repeat the same step. Yes? Question. Class interval 0 to 10, 10 to 20, 20 to 30, 40, 40 to 50. Frequency 4, 3, 6, 5. So in this, the only extra thing we need to do is calculating x on our own. X will be mid value. 5, 15, 25, 35, 45. Sum of frequency is 20. First, tell me what is mean.
32.75.
24.
25. Calculate variance. into frequency by sum of frequency.
$159.
Standard deviation is root 2 over variance.
$12.6.
So standard deviation by mean into 100.
52.5.
Then
Yes, ma'am.
then find out which is more consistent. First, series A, 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70. Now, frequency for data A, 5, 15, 20, 25, 18, 10, 7. Same table, frequency for data B, 7, 12, 22, 30, 25, and 4. You find the CV for A separately. You find the CV for B separately. Whichever is smaller is more consistent. So you need to have mid values. So we have to consider mid values of all of them. Mid values 5, 15, 25, 35, 45, 65. For data A, frequency 5, 15, 20, 25, 18, 10, and 7. Here, sum of the frequency is 100. You find the CV here. For data B, X is same. Frequency 7, 12, 22, 30, 25, and 4. Calculate for both of them. Here also the sum of the frequency is 100. So what's the verdict? Guys, what's the verdict? Answer. Which is better? Online, waiting for your answer. Yes, sir. So for the first one, what is the mean?
34.4.
Standard deviation 15.67. So CV is 45.55. For the second data, the mean is 32.5. Standard deviation 14.24. So CV is 43.82. Since CV of B is smaller than CV of A, B is more consistent. Clear?
Yes, ma'am.
Now, the last thing that we need is combined standard deviation. Now, among the central tendency, mean was the only one which has some mathematical property. Among all the dispersion, standard deviation is the only one which has mathematical property. So if I now talk about properties, all of them are defined. Which one is the most affected by extreme observation? Range. Which one is based on all the observation, both mean deviation and standard deviation? Which one uses absolute dispersion, absolute deviation, mean deviation, which can be calculated from median and mode? Mean deviation. Now, there was a property in central deviation. The absolute deviation is minimum when it is calculated from median. So, automatically, mean deviation calculated from median is the smallest one. Mean and mode, anyone can be larger, but the smallest value is obtained only when mean deviation is calculated from from median. Standard deviation is only calculated from mean. If CV of a data is smaller, then it is more consistent. Which one is used for open-end class? Only quartile deviation. Quartile deviation only uses the central 50% of the data. Then in case of standard deviation, it is the only one which has some mathematical property. Okay. Now the property of origin and scale is applicable on all of them. Now combine standard deviation. We have two series, series 1 and series 2. We'll be having number of observation. Here N1, this is N2. Mean X1 bar, X2 bar. Standard deviation. This is sigma 1, this is sigma 2 or S1 or S2. We first find out combined mean. Formula N1 X1 bar plus N2 X2 bar by N1 plus N2. Once we get that, we find deviations. This is after we have calculated the mean. D1 is X1 bar minus X bar. D2 is X2 bar minus X bar. Then combined standard deviation. Under root N1 sigma 1 square plus D1 square. N2 sigma 2 square plus D2 square. Whole thing by N1 plus N2. If it comes out for correct sum, leave the question. It's extremely long question. The data is wrong. Find out the correct standard deviation. If anything of that question of that sort comes out, we don't do the question. Written formula. Question. Number, mean, standard deviation. For boys and for girls. This is N1, this is N2. This is X1 bar, this is X2 bar. This is sigma 1, this is sigma 2. First, find out combined standard deviation. N1 into X1 bar plus N2 into X2 bar by N1 plus N2. Answer.
$24.
24. Then we calculate D1. Difference. 20 minus 24 minus 4. 30 minus 24, 6. This is your deviation. This is D1 and this is D2. So combined standard deviation. N1 sigma 1 square plus D1 square. N2 sigma 2 square plus D2 square by N1 plus N2. Calculate.
6.6, ma'am.
6.6. All of you got the answer?
Yes, ma'am.
So this is the concept of the entire chapter of dispersion. We'll now do the previous year questions. Okay, the first question, variance of 3, 4, 5, 8.
3.5.
3.5. The mean was 5. And then the variance formula, summation x minus x bar whole square by n. There will be no root over. The mean deviation about median. First, what is median here? If you arrange it, it becomes 11. It's already arranged. And then mean deviation. So summation x minus 11 absolute value divided by number of observations. 7.6. If all the observation in a distribution are increased by 6, then the variance of the series. If you add or subtract something, it doesn't matter. It remains unchanged. But if you would have multiplied by 6, then the variance, the options will be something else. If the observations are multiplied by 6, then the variance will be increased by 36. The standard deviation will increase by 6. Variance is the square of that. So that will increase by 36, square of it. Am I clear?
Yes.
Yes, ma'am.
This one, answer.
Equal to
Oh.
4.5.
Question number 4. If the standard deviation of the weights of the student in a class of 50 students was calculated to be 4.5, later on, due to some fault in weighing machine, the weight of each student was under measured by 4. That means all of them got subtracted by 0.5 or increased by 0.5. If you add or subtract something, will it matter? No, it will remain the same. So it will be equal to 4.5. It remains unchanged. For normal distribution, the quartile deviation is 2/3 of standard deviation. So quartile deviation is smaller than standard deviation. Quartile deviation is smaller than standard deviation. Right. If the formula for the standard deviation of first n natural number is under root n square minus 1 by 12. If it is only two numbers, it will be division by 2. These two were the formulas. The standard deviation of first n natural number is under root n square minus 1 by 12. Standard deviation of two numbers will be mod a minus b by 2. So here the standard deviation of first n natural number is 2. Do trial and error and tell me the answer would be
7.
7. 49 minus 1, 48. 48 by 12, 4. Root over 4 is 2. 7. The standard deviation is independent of change of origin. That is plus minus. Here, standard deviation. So it only matters with multiplication and division. So A by C. But wrong. It will be option D. Absolute value. If they would have written that A and C are positive, then we could have written only A and C. But right now we don't know because they are arbitrary constants. Clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Next, 9. Which of the following measure of dispersion is used for calculating the consistency? What do we use for calculating the consistency? Coefficient of variation. CV. CV is used to calculate the consistency. Standard deviation, the second formula, summation x square by n minus x bar square. Standard deviation is 7. This is 3390 by 30 minus mean square. Do trial and error. Answer would be
8, ma'am.
8. If the mean of frequency distribution is 100, this is x bar, CV is 45. CV is 45. CV is standard deviation by mean into 100. This is 45. So standard deviation will also be 45. CV percentage ही तो खुद ही. If arithmetic mean is 8 plus 4 by 2, then variance is
4, ma'am.
arithmetic mean is 8 plus 4 by 2. That means the two numbers are 8 and 4. The two numbers are 8 and 4. So variance of two numbers is 8 minus 4 by 2. Standard deviation. So standard deviation will be 4 by 2, 2. So variance is square of it. So it will be 4. Standard deviation of two numbers a and b is mod a minus b by 2. Variance is square of it. So it will be 4. Any doubts? Coefficient of mean deviation about mean for the first 9 natural numbers is. So for the first 9 natural numbers, find out mean. For the first 9 natural numbers, find out mean. Five. Now to find mean deviation, summation absolute value of d by 9. Subtract each number by 5. Positive value sign, then 9 divided by 9.
400 by 9.
20 by 9. So coefficient would be mean deviation by mean into 100. So 400 by 9. Clear? Clear?
Yes, ma'am.
Yes, ma'am.
Mean, standard deviation, median, quartile deviation, coefficient of quartile deviation. So mean, median is Q3 plus Q1 by 2. Median is 5. So Q3 plus Q1 is 10. Quartile deviation is Q3 minus Q1 by 2. So Q3 minus Q1 is 3. Use both of them. So Q1 will be, what do we need to find? Coefficient of quartile division. So Q3 minus Q1 by Q3 plus Q1 into 100. 30. Mean is irrelevant. I don't know why did they give us. Clear?
Yes, ma'am.
No.
Difference between maximum and minimum value of the data is known as
Range.
range. Formula for range of middle 50% of the data. For middle 50%, the range is quartile deviation. Quartile deviation formula is
Q3 minus Q1.
wrong. I said wrong. Interquartile range. They are not asking quartile deviation. Quartile deviation is semi-interquartile range. They have only asked you the range. So Q3 minus Q. We only need to find range. Quartile deviation is half of range. Is it okay?
Okay, ma'am.
17. What is the probable value of mean deviation when Q3 and Q1 is this? We can first find out quartile deviation. Q3 minus Q1 by 2. It will be 12.5. Now there was a relation. 6 quartile deviation equal to 5 MD equal to 4 standard deviation. So 6 into 12.5 equals to 5 mean deviation. So from here mean deviation will be 50. Is it okay? Yeah. First quartile. Q1 is 142. Semi-interquartile range. Q3 minus Q1 by 2 is 18. So Q3 minus Q1 is 36. Q1 is 142. So 36 plus 142, 178. Median will be Q3 plus Q1 by 2, 160. Clear? Quartile deviation. 2 by 3 standard deviation. We just use the same formula. Coefficient of quartile deviation is, it was Q3 minus Q1 by Q3 plus Q1 into 100, right? It's not none. This is the actual formula. If I divide both numerator and denominator by 2. So this is quartile deviation, this is median into 100. Option A. If every observation is increased by 5, all the measures of dispersion will be remaining unaffected. Clear? The standard deviation of x is 10. What will be the standard deviation? Whatever we add is irrelevant. So 5 into 10, 50. Range of 6, this one. Highest minus lowest, 10 minus 1, 9. Here the mean is 5.2. So mean deviation summation x minus x bar, absolute value by number of observation 5. Answer 1.44.
Yes, ma'am.
If variance of x is 23, then again for variance also if you add or subtract doesn't matter. But whatever you multiply or divide, that gets squared. So 2 square into variance of x. 4 into 23. 92. Average of two number is 20 and their standard deviation is 5. Average is a plus b by 2. You can do trial and error also. And the standard deviation is a minus b by 2. Trial and error. So option A is the correct answer.
Ma'am.
Yeah, CV. Standard deviation is root over variance by mean into 100.
A, ma'am.
28.02. If same amount is added to or subtracted from all the values, then the standard deviation and variance both will remain unchanged. Standard deviation of first n natural numbers.
N square minus 1 by 2.
Option A, under root n square minus 1 by 12. If arithmetic mean and CV of a random variable are this, then the variance of this is. Arithmetic mean, everything matters. So minus 15 plus 3 by 2 into 10. 0. Now CV is 40. CV is standard deviation by mean into 100. Mean was 10. So standard deviation is 4. So standard deviation of this will be 3 by 2 into 4, that is 6. Arey, रुको ना भाई. So standard deviation will be 6. So variance will be 6 square 36. The properties for standard deviation. Na? Guys, clear?
Yes, ma'am.
Mean and coefficient of variations are given. What will be the variance? Mean x bar is 20. CV is 80. Standard deviation by mean into 100 is 80. So standard deviation is 16. Variance will be 16 square 256. Clear? Mean deviation is least when deviations are taken from median. I don't know when it will be highest, but minimum will be when calculated from median. Mean of a series is equal to 100. Okay, it's again repeated. CV is 45. So standard deviation will be 45. We just did the same sum. Coefficient of variation is a relative measure of
Dispersion.
dispersion. Q3 minus Q1 by Q3 plus. Only into 100 is not done. So we can write it to be coefficient of quartile deviation. That's okay. If the standard deviation of first n natural number, that is n square minus 1 by 12 is equal to root 30. So n square minus 1 by 12 is 30. We need to find out the value of n.
19, ma'am.
If two random variable x and y are related by this, then standard deviation of y. Only the multiplication matters. 3 into standard deviation of x. It can't be negative, so we cannot have minus 3. First, variance is given. If variance is 4, then standard deviation will be 2. What is mean here? Mean is 8. So CV, standard deviation by mean into 100. 25. Clear?
Yes, ma'am.
Standard deviation for the marks obtained by the student out of 50 are out of 50, this is here. What is the mean? 25. Then standard deviation will be root over x minus 25 whole square by number of terms. Answer? Root 50.
Root 50.
All in clear? The standard deviation for the marks obtained by a student in monthly test is 36. Variance will be 36 square. So 1296. Which one of the following is not a central tendency?
Mean deviation.
Mean deviation. Range is 65. Maximum value of the set is 83. Then the minimum. 83 minus smallest is equal to 65. So the smallest value will be 18.
18.
Sigma square is 100. So sigma will be 10. So 20 standard deviation by mean into 100. So from here, standard deviation will be 50. Okay, points of inflection of a normal curve. This is probability distribution. Formula was x bar minus mu. Sorry, my fault. Mu minus sigma and mu plus sigma. From here, find mean and standard deviation. If you add 2 mu is 100, mu will be 50. So sigma will be 10. Sigma is what? Standard deviation. Standard deviation is 10. Normal. So mean deviation is 0.8 sigma. It should be a question of probability distribution. Huh? It is not a question of dispersion. 0.8 into 10, so 8. It's a formula in probability distribution. This question is not of a dispersion, it's a probability distribution issue. Standard deviation is dash times of mean deviation into quartile deviation. See, we know 4 times standard deviation, 5 mean deviation equals to 6 quartile deviation. Agree? Take anything. Say quartile deviation is 5. If quartile deviation is 5, then mean deviation will be 6. Standard deviation will be 30 by 4, so 15 by 2. Under root mean deviation into quartile deviation is root over 30. Right? Root over 30. Agree? No. So standard deviation will be how much times of this? Standard deviation divided by this. Standard deviation is 15 by 2. This is root over 30. 15 by 2 root 30. This will be root 15. 15 twos. So root over 15 by 8. First, this is the data. We have assumed any number, whatever you want. Let quartile deviation be 5. Now put here 4 standard deviation, 5 mean deviation, 5 into 6, 30. So from here, mean deviation will be 6. From here, standard deviation will be 30 by 4, which is 15 by 2. You want to find out standard deviation is x times that, right? So standard deviation equal x times this, 15 by 2. Mean deviation 6. Quartile deviation is 5. 15 by 2 equal x root 30. Root 30 is root 2 into root 15. So root 15 left. This is 2 root 2. I'm sending 2 inside the root over. So root over 5, 4 into 2, 8. X is under root 15 by 8. X is under root 15 by 8. You can take quartile division to be any number. Online, is it okay?
Yes, ma'am.
Yes, ma'am.
Okay, quartile division of these numbers. So we need to find out Q1 and Q3 first. What is Q1 here? We have to arrange, remember, 8, 15, 36, 38, 40, 41. N plus 1 by 4th observation, that formula. So Q1 will be 1.75th observation. So 8 plus 0.75, 15 minus 8. So 13.25. Q3, 3 into n plus 1 by 4th observation, 5.25th observation. This will be 40.25. So quartile deviation will be Q3 minus Q1 by 2. So 13.5. Clear? First consecutive 5. So under root 5 square minus 1 by 12 root over 2.
Yes, ma'am.
If the profits of a company remain same for the first 10 months. If the data is constant, then mean, median, mode are the same constant. Standard deviation and variance is 0. So what is standard deviation? Change, deviation, right? So if all of them are same, how can you have a deviation? Deviation will be 0. So standard deviation, any dispersion, basically. Standard deviation, variance, all of them will be 0. Coefficient of quartile deviation is 1 by 4. Then Q3, 1 by 4 is in decimal. Huh? 1 by 4 is decimal. We can see that, na? 0.25. 0.25 means they haven't multiplied 100. So quartile deviation is Q3 minus Q1 by Q3 plus Q1, 1 by 4. You can do trial and error. If you use 5 and 3, 5 minus 3, 2, 5 plus 3, 8. It's correct. 5 by 3 is the answer. Q3 has to be larger. How can, see, C and D are wrong because Q3 is more than Q1. Online, did you all understand what did I do? I just put the value of 5 instead of Q3 and Q1, I put 3. Since it was in decimal, that means they haven't multiplied 100.
Yes, ma'am.
Yes, ma'am.
The sum of mean and standard deviation of a series is A plus B. If we add to each observation, then sum of mean and standard deviation. If you add 2 to all the data, then the mean increases by 2 and the standard deviation remain unchanged.
Right.
So their sum will only increase by 2. The sum will only increase by 2 because standard deviation won't change. Did you all understand?
Yes, ma'am.
What will be the probable value of mean deviation? Same. First find out quartile deviation. Q3 minus Q1 by 2, 12.5. We have done the sum. 6 quartile deviation equal to 5 mean deviation. So mean deviation will be 15. Find the mean deviation. It's a repeat sum again. 1.44. 256 was the answer. Okay, that was the last. Did you all understand the chapter?
Yes, ma'am.
Yes, that's the end of dispersion.